All right, measures of position. So some common measures of position are quartiles. So our lower quartile is also called Q1 or the first quartile. Upper quartile is also called Q3 or the third quartile. And something common that we will refer to in this type of with this type of content is 5-number summary. Okay, so your lower quartile is the median of the lower half of data, and then your upper quartile is the median of the upper half of data. You should have experience calculating this by hand in Algebra 1. We are going to use our TI-84s to do it in this class, but I will refresh your mind on how to do it by hand in case you do not have a TI-84. 5-number summary, we want the 5 numbers that are needed to make a box and whisker plot. So those 5 numbers are minimum, Q1, median, Q3, and maximum. In this example, it says the number of hours Lena worked each week for the last 12 weeks were listed here. Okay, so find the 5-number summary. When finding 5-number summary, I recommend finding the minimum, the maximum, and the median first because they are the most straightforward. Okay, first thing we have to do is order these from least to greatest. So 10, 12, 13, 14, 15, 16, 18, 19, and then we have 20, 20. Oh, we have 18 twice. 18, 18. 19, and then we have 20, 20, and 21. Okay, so just by doing that, we know that our minimum is going to be 10 and our maximum is going to be 21. By doing some calculations, or not really calculations, but by counting one by one, we can locate our median right in the middle, which should be 17. Okay, so right now we have 3 out of our 5 numbers for our 5-number summary. Okay, 10, 17, and 21. And then let's move on to the quartiles. So our quartiles are going to be the median of the lower half and the upper half of numbers. So 17 is our median. It's right here in the middle. So now we've broken our data into a bottom half and an upper half. So think about the median of this bottom half, 10, 12, 13, 14, 15, 16. If we figure out the middle number, it's going to be in between 13 and 14, which is 13.5. Same thing with the upper half, 18, 18, 19, 20, 20, 21. It's going to be halfway between 19 and 20, which will give us a third quartile of 19.5. Okay, 13.5, 19.5. It's a quick refresher on finding the 5-number summary. I will link a separate video for using your TI-84 to do that because it's much more quick. Okay. Next, with the idea of position, is the effect of an outlier. So up until this point, we've given you the definition that an outlier is a really, really big or a really, really small number because that is the easiest way to help you understand it when it's new. In general, though, there is a mathematical way to tell whether a number is an outlier. And the way that we decide that uses the interquartile range. So interquartile range, or IQR, is the difference between our third quartile and our first quartile. So it's Q3 minus Q1. And then an outlier is, the new definition we want to work with is right here. It's outliers are values that are 1.5 times the IQR above or below Q1 and Q3. So 1.5 times the IQR, multiply that, and then add it to Q3 to get the highest possible value that a number in a data set could be without being an outlier, and then subtract it from Q1 to figure out the lowest possible number that a number in a data set could be without being an outlier. Okay. So when doing this, I recommend writing out your Q1, Q3, IQR 1.5 times the IQR and below or above. Those are the 5 steps I recommend taking for this going forward. So this example says number of hours Lena worked each week for the last 12 weeks were those numbers. Check for any outliers in the data. So we know from what we just figured out in the 5-number summary that Q1 is 13.5, Q3 is 19.5. So by subtracting those two, we get the IQR to be 6. to figure out our range for outliers, we want to multiply 6 times 1.5. And when we do so, we get we should be getting 9, not 3. Ignore the 3. Should be getting 9. Okay? So numbers that are 9 above Q3 or 9 below 13.5 would be considered outliers. Okay? So 19.5 plus 9 would be, let's see, 28.5. Yeah? 28.5, so anything above 28.5 and anything below, let's see, 5.5, does that sound right? 4.5? 13.5 minus 9, it's 7 p.m., y'all. It is bedtime. Okay, but either way, we would get a range. Then we check and look at our data set and see, are there any numbers above 28.5 or below 4.5? And we look and see no. So we don't have any outliers in here, but if we did, then we would write out, you know, if 45 were included in the data set, we would say 45 is an outlier. Something like that, okay? We don't have any outliers, so that's not going to happen here. Okay, that is all. Last thought with outliers is that they can affect the mean, median, range, and standard deviation. But note that it affects the mean more than the median, because think about the way that a mean is calculated. If you're taking all of the values in a data set and dividing it by the number of numbers in the data set, a really high number or a really low number is going to pull that average up or down. Versus if we, with a median, if we just have a list of values, we're alternating, crossing them out on either end, so the middle numbers are not really going to be affected as much by an outlier. Okay, that is all. Take a look at page 14. Have a great day.